All right, so today we're going to do bisectors of a triangle, all right? This entire chapter is going to be about special relationships inside of triangles, yeah? So the first word we need to talk about is a perpendicular bisector. In a couple lessons from now, 6, 7 lessons from now, you're going to do a lesson where you're doing constructions, yeah? And in constructions, here, we're going to immortalize this. So right now, Mr. Gillespie said 6, 7, and then the whole class laughed. Now they're crying because they're going to have 3 extra homework problems. You're welcome, everybody. So, in 6 or 7 lessons, anyone else? We are having 3 extra problems for being annoying. Perpendicular bisector, what it is, if you have a line, what the perpendicular bisector does, it's the line that cuts it straight in half, so it makes this side equal to this side, and it does something else. And it makes a 90 there, right? That's called a perpendicular bisector. Yeah? So, what did I go to? So it bisects the line and it makes a right angle, yeah? Now be careful with the perpendicular bisector theorem. You would think, when I first did this, I thought the perpendicular bisector theorem said, something like you can cut a line in half at a right angle, but it has actually nothing to do with that, all right? If you read this with me, if a point is a perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. The first time I saw that, I didn't really know what it was talking about, but here's what it's saying. This is all it's saying. Okay, so that line is a perpendicular bisector of that line, yes? All right? What they're saying is, if you pick any point on this line, yeah? Let's say I pick that point right there. That point will be equidistant to the endpoints of that line. So this distance will be equal to that distance. You can quickly prove it. It's not hard to prove at all, right? You already know this is equal to this, right? Because you bisected it. You know that's a 90 because you perpendicular bisect it. And what else is true? This is equal to itself. So now you know that this triangle is congruent to this triangle, which means those must be equal. And that means I can go anywhere. I can come up here and do the same thing, yeah? Put the dot up here. And that point, come on, you suck. That point is equidistant to the endpoints of the line segment, yeah? All right. And then the converse of that says if 2 points are equidistant to the endpoints, then it must be on the perpendicular bisector. All right, both are useful. All right, the last thing we're going to talk about is called the circumcenter. If you take we're going to learn all these special points inside a triangle, all right? So if you have a triangle, and in the next chapter when we do the constructions, we're actually going to create all these points, yeah? If you create the perpendicular bisector of each side, yeah? So let's say that one's there, and that one is, say, there, yeah? It will create this point, right? These are all 90s, right? And this is equal to this is equal to this is equal to this, right? They will intersect at a special point. The intersection of the perpendicular bisectors of each side will intersect at a point called circumcenter. All right? Got it? And it does some special things inside the triangle, right? Oh, I don't think I wrote it there. What's it say on the card? What's the circumcenter? Yeah, I know, but it does something in the triangle. Is it the one? Oh, is it the one that does this? So that point, all right, are we sure on that? Yeah. That point is going to be equidistant to the three sides. These are going to be equal, yes? And which then means if it's equidistant, that's going to be like the center of the circle that would go around that shape. Yeah? Are we sure on that? That was a lot of help, thank you. Where did I put it? Oh, final set. Be in the last red set. Notice how you're using the wrong set. Which is exactly what Joseph said. Good job, Joseph. You get immortalized in a video for the next. Oh my gosh. See, the trolliest program in the history of programs. All right, that's an important point. When you find that point is going to be equidistant from the three sides, which means that's the circle that will go around it exactly. Does that make sense? All right. All right, so let's work through this a little bit. Find the measure of FM, right? Now, what do we know there? What is FK doing there? It's bisecting it, and it's perpendicular. So it's a perpendicular bisector, which then means what? FG must be equal to FM. So FM is easy, is not that pin. FM is 2.8. Simple? All right, letter B. BD is the perpendicular bisector, right? So that you would then know that BA must be equal to BC, but what else is true about CD and AD? If it's a perpendicular bisector, that must be equal. So 5x minus 6 must be equal to 3x plus 8, yeah? So we get what? 2x minus 6 equals 8. So we get 2x equals 14. So x is 7. Done. Easy? Example 3, in the world's worst drawn picture. Right? What do we know? It's perpendicular-ish. And those two sides are equal, 5 and 5, right? So it's a perpendicular bisector, yeah? So that means since that is a perpendicular bisector, then XW will also be 7.5. Now, it's not the converse. The converse would say if they're equidistant. Actually, here, we're about to do it for BF. Step part B, right? What do we know? This is perpendicular. Now watch how this works. This is perpendicular, right? This is perpendicular, and these are equal. Oh my gosh. I'm just going to be real nice and slow today. And those are equal, which activates the converse, right? Which says what? That must be bisected, right? So it makes BF what? 4.2. All right, here we go. Okay, so what do we know about angle? Point P is the circumcenter, right? So if it's the circumcenter, what do we know? No, that's not what we know here. If it's a circumcenter, what is it doing to each side? It's a perpendicular bisector, so that means this is equal to this. That means this is equal to this. That means this is equal to this. Be very careful in your mind. The perpendicular bisector does not have to go through the point K. See how this is cutting it here? It doesn't have to. Your brain kind of wants to make it go through the vertex, but it doesn't. The only time that will happen is when it's isosceles. So that because that one goes through there, you could assume that it's isosceles, but we're not proving that right now. All right, we got that? Okay, what is PE going to be equal to? That's it? P what? PN, no. So P, let me do it again. So this one right here, what is this going to be equal to? It's not drawn there. What is that point? Because we just said P is the circumcenter, right? Which means it's equidistant from the three vertices. So that's equal to this, and that's equal to this, yeah? They didn't draw it in, but those are true. Those are all going to be equal. Because remember what a circumcenter does. It's the circle that would touch all 3 points on the triangle, yeah? All right, so let's go. Let's see if we can answer this. What's MY congruent to? All right, EY. All right. Anything else? No. I mean, you could probably get, yeah, I'm not going to go deeper with that. All right, KP? MP and EP. That's what a lot of people will miss. MN? KN or NK, yeah? And RK or Ker. Ker's better. All right, got it? Pretty simple? All right. Listen, you either know that relationship and you get it right every time, or you don't know the relationship and you miss it every time. Okay? Angle bisector theorem. All right? So let me explain what an angle bisector is. We're going to learn how to construct it next chapter. Angle bisector 7. If a point is on the bisector of an angle, then it's equidistant from the sides of the angle. All right? From the sides of the angle. So let me explain that. So if I have this angle, right? All right, and that point, this line right here is going to bisect this, right? And what we're saying is pick a point on that line. It will be equidistant from both sides. All right? Now this is slightly different because it will go shortest distance, right? So if I extend this out, right? What's the shortest distance from this point to this line? The perpendicular. So that will be equal to that. Not that, that. See what it's doing? So that point will be equidistant to the angle. Okay? That's what it's saying. That's the angle bisector, not the perpendicular bisector. Okay? The converse says, if points are on the interior of the angle are equidistant from the sides of the angle, then it's on the perpendicular. What you're saying is, if you have this line and you say this is perpendicular to this, then that must be the angle bisector. Kind of logical. All right. And then we got the incenter, right? If you take all the angle bisectors, they create a point that's incenter. That's equidistant from the sides of the triangle. Let me explain that one to you. So, all right, so say I have a triangle, right? And what do I construct? The angle bisectors, right? And I'm fudging this a little bit, but let's say they cross there, yeah? Okay, what is this saying? So this is equal to this is equal to this angle is equal to this angle. It doesn't tell you anything about the side, just so you know. All right? This point is called the what? An incenter. And the incenter is equidistant to the sides. Yeah? So this point, and I think this book screws this up royally all the time, will be equidistant from the three sides. That doesn't mean that this is equal to this is equal to this, which the book is notorious for doing. It's this, this, and this. You see it? So those points, yeah? But I feel like I'm doing that one wrong. I feel like I'm doing that one. My spidey senses are tingling, and I feel like I'm doing that one wrong. That is equidistance from the sides. Maybe it is. No, I think I'm actually wrong on that one. No, I actually think it's this one. I had to look that one up real quick. I don't play with these very often, so. It'll take you 5 minutes to find it again, isn't it?
Yeah, the circle is such a center of the largest circle by the center.
All right. I'm pretty confident it's these 3 points, yeah? Oh, you know what? Those will be tangents. Because wherever it touches the circle exactly once will be a right angle. Yeah, we're okay. All right, so let me say that again because I did mess you up. When you find the end center, okay, it will be on those 3 points, right? It will, those will be equal. All right, sorry about that. So, here we go. What do we know? MR is the angle bisector. So we know angle 1 and 2 are equal, correct? So we know that, this is not hard, right? We know that Gillespie should change his pen. 5x plus 8 is equal to 8x minus 16. So we get 3x equals 24, so x is 8. What's the question? Find x. All right, we're done. All right, so this next one, it's a pretty poor picture, especially on the left-hand side. But those are both what? Okay, not just same distance, but the shortest distance, right? The shortest distance. Yeah? Be very careful. They're going to try to trap you later on. Don't copy this, but just watch. They'll do this, and they'll say something like this. And then you're going to say, oh, that's the perpendicular bisector. No. What does it have to be? It has to be the bisector. No, these have to be 90s. It has to be shortest distance. So be very careful with that. That's a trap. All right? Not any distance, the shortest distance. All right, and that is the shortest distance. Why? Because it's a right angle, right? So those are equal, so that means ABE is 43. Easy. All right, Yaba? What do we know? 8 and 8 are equal, and they're at right angles, so they're shortest distance, so it must be on the angle bisector, yes? So that's 47. So Yaba is 47. Now let's look at any more of these. Are any more of these interesting? It's hard to tell on letter C, but you see that little tick marks at the bottom? At the top there? They're hard to see on your paper, but they are saying they're congruent. Really poorly drawn, yeah? But those are equal, so that means what? That those two must be equidistant, right? So we get what? X minus 8 equals 1 plus 8. So we get x equals 9. What's the question? MK would be what? 2 times 9 plus 1, which is 19, right? All right. I don't think I'll do the rest of those there. All right. Watch. I think this is where the book gets jacked up beyond belief. All right. So this is equal to this, right? The book is making a humongous mistake here. I think this right here proves it. Yeah. All right. What they're trying to say that these three are equal. Yeah. Read through what the in-center is. Okay? Maybe we're okay. So they're saying this, right? See, the problem, so here's the problem with this. If that's true, then these points, math team knows this, but these are tangent, yes? And if those are tangent to the circle, then that implies, you don't know this yet, and this is where I think they're messed up. If you draw a line that is touching a circle at one point, that's called a tangent. And the tangent always makes a right angle with the middle. You see what it's saying? And there's no way that that point can be the tangent, because that would imply, because I could draw it like this. Look, I could draw the angle like this, right? But that would still give me the same point. I'm getting mixed up there. That does not have to be a right angle. Yeah, that does not have to be a right angle, unless it would change it. I'm really tempted to say the book is jacked up there. Give me a second. What are you on, 5-1, right? Yep, I'm all right. All right, good. My instinct was right. The book is messed up here, okay? All right. All that's telling you is that's the point that's going to be equidistant from the sides. It may be at those points, but it may be somewhere else. Yeah? But this distance will be equal to this distance will be equal to this distance. They'll have to be at right angles. And that doesn't have to necessarily be at right angle. If it's an equilateral triangle, it would be. All right? But it's not. So I'm going to back up here just so you can see that. Not that far. And then it's just going to stay there, huh? Yeah, nice. Way to go, crappy program. And now it's just locked to it. All right, let me explain this to you. All right, so if I create the angle bisector, so say it's there, and just for the sake of it, it's there, yeah? Look, that doesn't mean that this is equal to this is equal to this. It doesn't even look like it is, yeah? So that is not the circle, yeah? Unless you're drunk. Even then, it's probably not the circle. What is it saying? This is the point that's what? Equidistance, right? So these would have to be dropped at 90s. And I don't know how that's going to look here, right? But something like that. Those would be equal if I drew that point more carefully, yeah? So the only time it's going to be equal is if it's equilateral. If it's equilateral, then you create them and they actually do make 90s. But anything else can't be a 90. If that's the only one that makes 90s, if you skew the shape, it's not going to be that anymore. It can't be 90 anymore, yeah? So be very careful. The book is wrong a lot of the time. All right, so here we go. Ready? Oh, look. If this guy that I'm pointing at here was an angle, which one would he be? No, not acute. Nice try, though. PHU. PU. Got him. That was a good one, huh? All right. That was a good one, huh? But we're not going to say your name, so we won't tell them who's stinky. Joseph. All right. All right, so what do we know? Let's go through this. What do we know about MU? They just made their mistake. They just made the mistake here. Yes? They're trying to say that this is a right angle. Yeah? And And if you tried to make, I mean, you can just see it. If you tried to make it touch there, it would do something like this, right? It would actually be off of it. They're so, I hope they don't do this later on. What do I know about MU? See, if they had created this point right here that was at a 90, and you said this is a 90, and they created this one that's at a 90, then that would be it. Yeah? Yeah, we're just going to leave that alone. Just be careful with that. All right. The other ones I think are much easier. What about UGM? UGM is this angle right here, yes? What do I know about it? It's equal to that one, right? 28. And PU? PU? PH, yeah, 21. And HU? What do you know about HU? I'm going to say absolutely nothing. What they're trying to do, see, I know what they're trying to do, and they're so, God, hey, they're probably old and decrepit by now, so they probably don't even know what the internet looks like. But they suck so bad at what they're doing here. If they had a family of highly trained lemmings write this book, it wouldn't be any worse. What are they trying to say here? They're trying to say that this is 13. Why? Because they're trying to say this is a right angle. But obviously the right angle's over here. Yes? Yeah? So if we created this new that is at a right angle, then that would be a right triangle. You get what I'm saying? All right? So let's say that's 5, right? Now what would have to be 12 then? Not this distance, this distance. Yes? It's a train wreck. Then it would be 13. All right. Worst video I've ever made. No, I've made worse, huh? And this was the one with the popcorn sound? Yeah. You think this one's bad, go watch the popcorn video. All right.